Hello grade 8 students. For today, we will be discussing triangle congruence postulate. In today's learning target, you should be able to illustrate and appropriately use the SAS, ASA, SSS postulates, and the SAA theorem to verify congruent triangles. What do we mean by congruent triangles? Two triangles are congruent if and only if their corresponding parts are congruent. I've already discussed this on our previous video playback. What are the theorems or postulates that we can use in identifying triangle congruence? The first postulate is what we call the SSS postulate or the side-side-side postulate. It states that if three sides of one triangle is congruent to the corresponding sides of another triangle, then the two triangles are congruent. So as you can see, all the sides of our first triangle corresponds and congruent to the second triangle. We also have the SAS postulate or the side angle side postulate. If two sides and the included angle of one triangle is congruent to the corresponding two sides and included angle of another triangle, then the two triangles are congruent. As you can see on the illustration, there are two corresponding sides and the angle should be inside those two corresponding sides. We can say that this is congruent through the use of the side angle side postulate. Let's have the ASA postulate or the angle side angle postulate. So if two angles and the included side of one triangle is congruent to the corresponding two angles and included side of another triangle, then the two triangles are congruent. So as you can see on our figure, there are two corresponding angles and the included side should be in between of those two angles. We can say that these two triangles are congruent because of the ASA postulate. Last but not the least is our SAA theorem or the side angle theorem. It states that if two angles and a non-included side of one triangle are congruent to the corresponding two angles and a non-inclusive side of another triangle, then the two triangles are congruent. So in this figure, we have two corresponding angles, yet the corresponding side is not in between of those two angles. We can say that these two triangles are congruent because of the SAA theorem. Now, let's identify whether the following triangles are congruent and identify the postulate or theorem used. So in these first figures, we know that these triangles are congruent because of the SSS postulate. Next, we have this figure. So we have two angles and one side. These two angles or triangles, are congruent because of the SAA theorem. These triangles are also congruent because we have two corresponding sides and there are one corresponding angle which is in between of our two corresponding sides. So this is congruent under the SAS postulate. But how about this last figure? As you can see, all the angles of the first triangle corresponds to the second triangle. Are these two triangles congruent? No, these triangles are not congruent because we do not have the AAA theorem. We do not have that. It also not congruent because angles can be congruent but the sides of it may differ to one another. Now, Identify the missing congruence to make the triangle congruent using the indicated postulates or theorem. So I'll be giving the postulate used and the figure, and let's try to put the tick mark or the missing tick mark on our figure. So in here, we have here two corresponding sides, and we must have an SSS postulate. So what is the missing tick mark? The missing one is the side CA and side AC. So to make this SSS postulate, this is the tick mark which is missing. Next, we also have this figure, and we need to apply the ASAA theorem. So as you can see here, we have one corresponding side and corresponding angle. So we are looking for another angle. So the missing angles are angle M and angle J. This completes our theorem. Sir, why cannot we input the angles on angle G? We cannot put the missing angle on angle G because it will become ASA postulate or ASA postulate. It is different from the SAA theorem. Here, let's apply the ASA postulate. So we have here one corresponding side and corresponding angle. To complete this theorem or postulate, the missing angles are angle B and angle B. So we have here angle, side, angle, postulate. Last one, let's apply in this figure the SAS postulate. We have here two corresponding sides, and the missing tick mark is for the angle. So here, the missing angles are angle P and angle R. Now, let's identify the correct reason to prove that the two triangles are congruent using the figure on the side. So AC is congruent to CA. They share a common side. So we can say that the reason here is the reflexive property of congruence. So if AC is congruent to itself and the other side corresponds to the other side of another triangle, can we say that triangle ABC is congruent to triangle CBA? Yes, they are congruent because of the SSS postulate. Let's have the second one. Angle NCM is congruent to angle BCA because they are congruent because they are vertical angles, and if vertical angles are congruent, it is under the vertical angle theorem. Now, can we say that triangle MCN is congruent to triangle ABC? Yes, we can say that. Why? Because of the SAA theorem. Let's have our last example. So angle A is congruent to angle B, and we know that these two angles are right angles. So all right angles are congruent. So we can say that triangle BAC is congruent to triangle EBC because of the ASA postulate. So that's all for today. Do not forget to access your Creeper accounts. Thank you and God bless.